Hi students, welcome back to the class. Today I am going to explain the second topic, carbon dioxide and oxygen from the lesson air and atmosphere. So today I am going to explain about the carbon dioxide and the functions of carbon dioxide, use of carbon dioxide and at the same time oxygen also. Okay, first of all, carbon dioxide. So carbon dioxide is an odorless and colorless gas. Odorless and colorless gas is comparatively very less quantity in the atmosphere. So the carbon dioxide is very important for all the living organisms. For example, the carbon dioxide is very necessary for the photosynthesis, and the human beings and all the animals or all the living organisms liberating or release out carbon dioxide to the atmosphere. So according to this way, the carbon dioxide is very useful for the human and animals and all the living organisms. Come, let's explain about the carbon dioxide. And what is the symbol and chemical formula of carbon dioxide? Is a CO2. Okay. The first of all, the uses of carbon dioxide. First one, it helps to maintain earth temperature. It helps to maintain the earth temperature. How it's possible to maintain the earth temperature? So, I hope all of you know the burning of fuels and any other burning process that will mainly carbon dioxide is emitted into the atmosphere. So, that sunlight, the solar rays is coming towards the earth. This type of gas, carbon dioxide, is also trap the solar radiation from the re-emitting. So according to that one, the solar radiation is still remaining in the atmosphere, that help to us for the getting optimum temperature for surviving the all living organisms. Very simple. Once again I will explain this topic. It helps to maintain earth temperature. Other simply we can say is a greenhouse effect. What is a greenhouse effect? The greenhouse effect means the solar radiation coming towards the earth surface, and with the help of this carbon dioxide gas that prevent or protect or help to us for rebouncing, that means re-emitting from the earth surface to outside. So that carbon dioxide help to us for stopping or help to us for preventing in the atmosphere. According to that air temperature maintain the help of carbon dioxide. As a result, we are getting the optimum temperature for maintaining our life. The first one that. So second one, for the photosynthesis. I hope all of you know this process. The photosynthesis. What is the photosynthesis? The green plants synthesize their own food in the help of sunlight and carbon dioxide. So here also the carbon dioxide is very important for the all green plants, plants as well as to the that help to the human beings also. So during the photosynthesis, that plants receive and intake carbon dioxide and sunlight, the help of the sunlight. Okay. So the reaction between the water and the carbon dioxide combined together into form glucose and oxygen. The plant produces the glucose. That glucose will be utilized for metabolic activities, and oxygen is also produced during the photosynthesis. That photosynthesis, the oxygen is sent into the atmosphere. So according to this way, the carbon dioxide is very helpful for us. So that during the photosynthesis, the oxygen is produced. Oxygen is produced and sent into the atmosphere. That oxygen is helpful for the human beings and all living organisms. So here is also one mutual understanding between the plants and the animals. So we are giving the carbon dioxide, and that plants is give the oxygen. So mutual understanding between plants and the animals. Next one. So one more point I want to convey, that's the global warming. So the increase in the carbon dioxide in the atmosphere, what happened? The increase in the concentration of carbon dioxide in the atmosphere that leads to global warming. What's the global warming? I told you in the first point, greenhouse effect. In the moderate or small amount of carbon dioxide in the atmosphere that help to maintain the earth temperature balance. If this minimum level is exceeding, that means leads to high concentration of carbon dioxide to large number of and large quantity of solar radiation is protected or prevented in the earth's surface according to the increase in the temperature per day. According to that increase in the temperature in the atmosphere that turn to global warming. Turn to global warming. Okay. And third one, carbon dioxide. So this carbon dioxide is helping to us to extinguish the fire. Extinguish the fire. Simply, we are using carbon dioxide in the fire extinguisher. Help to control the burning. Help to control the burning. So this is a non-supporter of burning. Non-supporter of burning carbon dioxide. Next one, carbon dioxide dissolves in water. Some quantity of carbon dioxide dissolves in water. For what purpose? The loads of aquatic plants is living in the water, so that aquatic plants also need carbon dioxide. So the carbon dioxide little bit dissolved in the water that will help to the aquatic plants. These are the main functions and main use of carbon dioxide. First one, that carbon dioxide helps to greenhouse effect. Simply maintain the earth temperature balance. Second one, for the photosynthesis, the carbon dioxide is very important component. And if the excess amount of carbon dioxide that leads to global warming, that's dangerous to the all life forms. Next one, carbon dioxide extinguishes a burning fire. So carbon dioxide helps to us to control the fire. Next one, carbon dioxide dissolves in water for aquatic plants. Okay, these are the few uses or functions of carbon dioxide. And next one about oxygen. Okay, what is the symbol of oxygen? O. Okay, so now all of you know that importance of oxygen and how they help to us and how that is needed in our life. So now I will give you almost all the details about the oxygen. Okay, so oxygen is a life supporting gas. Oxygen is a life supporting gas. Okay, so just before I want to give some information about the discovery of oxygen. And the earliest time, the ancient time, that some of the scientists are trying to discover the unknown gas, and that gas is oxygen, and lately newly is named oxygen also, and their importance and numerous information about that. The first of all, we want to discuss about these three people and three different scientists. On the earliest time, the first of the Swedish scientist we call Wilhelm Skelly. In the year of 1772, he started to prepare the unknown gas, and he studied and he reacted with different type of chemicals or substance. Well, the Carl Wilhelm is reacting with two different components, and by during that chemical reaction, what happened? One unknown gas is produced, and that gas is also helped to burn the substance properly. So that time he is identified the gas, but is not given the name and what is the name of the gas, how they help, and this much details is not discovered in the time of 1772 to 1777. So and after and before also, before this between this research and before one of the most famous scientists, Joseph Priestley, that 1774, he is also start to discover, start to identify and trying to identify the gas. He is also practicing and doing the experimenting. So according to during that experimental time, he is also noticed one of that gas that helped to burn the substance, burn the candle, and candle is also blowing and producing the heat and burn properly. And this gas is also given to that some mouse, and mouse is also active, more active. So accordingly, that is one of the unknown gases produced, but he is also failed to find the name of the gas and giving the more information. And finally, the Anthony Lavoisier, that 1784, he is discovered and identified and give the name of the element, that is oxygen, and given the symbol also O. Okay, so according to this way, the different scientists is discovered and experimentally trying to give the proof about the oxygen, and the first two are failed to give and identified the gas but not given a name. And finally, the 1784, the Anton Lavoisier is given the name of the element, that is life supporting, or the for the help of the combustion, that one gas is needed, that name that gas is given a name also, the name is oxygen and symbol O. This much about that discovery of oxygen. And next one, the preparation of oxygen. Preparation of oxygen. How we can prepare in different ways. Okay. The first of all, the laboratory methods. How we can prepare oxygen in laboratory. Okay. And a few examples and a few methods I have given here only. The first one, catalytic decomposition. Catalytic decomposition. So here, H2O2, hydrogen peroxide. So we are going to prepare the oxygen in the help of hydrogen peroxide. The two molecules of hydrogen peroxide. So this hydrogen peroxide want to break into form the oxygen and other form. No? So we need one of the catalyst. We need one of the catalyst. So the catalyst is given here. The name of the catalyst is manganese oxide. Manganese oxide, MnO2. So what is the need of the catalyst? So that one of the chemical compound that help to this reaction. So this manganese oxide is speed up the chemical reaction as well as not involved in the chemical reaction. So this one is also helpful to break the hydrogen peroxide. Break the hydrogen peroxide and into form it to product it. The first one is two molecules of water. The water is also produced, and the same time oxygen is also produced. So according to this way, the catalytic decomposition, the hydrogen peroxide is splitting in the help of the manganese dioxide, manganese oxide, and it forms hydrogen of water and the oxygen. According to this way, we will get the oxygen. So okay, this is one of the method to separate the oxygen in the help of in the laboratory, in the lab. Okay, the name of the process is catalytic decomposition. And second one, the from potassium chloride, in the help of the potassium chloride. So here, the two molecules of the potassium chloride. Potassium chloride. So here also, the potassium chloride want to split and want to in the chemical reaction. We need one of the catalyst. We need the one of the most important catalyst. The catalyst name manganese dioxide, MnO2. So in the help of the manganese dioxide, the potassium chloride is splitting into potassium chloride and the three molecules of oxygen. Three molecules of oxygen. So here, so this oxygen, according to this method, we are easy to separate the oxygen. So these two methods, all of you want to learn properly. The first method, catalytic suppression or catalytic decomposition, and next one from the potassium chloride. According to these two ways, we are possible to separate the oxygen. Okay. And the next one, the industrial method. Next, we are going to check how we can separate or produce or manufacture the oxygen in industrial method. Okay. So here is two methods given here only. The first one, we can easy to separate that oxygen from liquid air. Liquid air. So the air means, I hope all of you know, mixing of different gases. So here we want to separate it, during this process we want to separate that oxygen. So before that one, we want to first collect that liquid air, and first we remove that dust particle, water vapor and carbon dioxide. This much gas we can separate it. The remaining, the nitrogen and the oxygen only. So this oxygen and nitrogen we will allow to that fractional distillation chamber. Fractional distillation chamber. So that unwanted dust particles, water vapor, carbon dioxide removed, then after we will send into the fractional distillation chamber. So the fractional distillation chambers help to us for separating that components according to their boiling point. Okay. So here is also nitrogen and oxygen both are different character and their boiling points are also different. So according to this way, we can easily to separate the oxygen from nitrogen and liquid air. Okay. And next one, by electrolysis. By electrolysis of water. By the electrolysis of water means that we want to collect the water and giving that first acidify the water. Then after we will pass the electricity. We will pass the electricity into the water. Then according to this, with the help of that electricity, what happens? That is the water will be splitting into their ions. That means hydrogen and oxygen will be separate. So according to this way, we are easy to separate the oxygen from by the help of electrolysis process. By the electrolysis process, we can easy to separate the oxygen also. Okay. So these two are the method of industrial method to separate the oxygen. Okay. And next one, the physical properties of oxygen. Now we are going to the next topic, physical properties of oxygen. So what about the density and what is the solubility in water and what is the effect of litmus? So few points we want to discuss about the oxygen. That is called physical properties. We can say this much qualities is properties called physical property. So first one, density, about the density. Okay. So the oxygen gas is heavier than air. Heavier than air. Comparatively other gases, the oxygen gas is heavier. Okay. So density compared to the other gases, oxygen has a high density. And solubility. And the oxygen is fairly soluble in the water. A little bit only soluble in water. Okay. And next one, effect of litmus. Effect of litmus. So oxygen is a neutral gas. There is no changes in the help of litmus. There is no possibility to change. Next one, the boiling and freezing point of the oxygen. Boiling and freezing point. So here that oxygen is a liquid phase minus 180 degrees Celsius. So we want to liquefy the oxygen, that it's only possible minus 180 degree Celsius. Okay, and so the oxygen want to freeze. So it is possible only minus 218.4 degrees Celsius. So these are the basic properties of oxygen. Physical properties of oxygen: density and heavier than the gas, and solubility, sparingly soluble in water, and effect of litmus. The oxygen is a neutral gas. There is no changes observing in the litmus paper. And boiling and freezing point of water oxygen is liquid phase minus 180 degrees Celsius, and freezing point minus 218 degrees Celsius. These are the basic information about the oxygen. So all of you study this topic carefully, and today I am concluding this topic.